Manufacturing techniques of multiphase open-pore foams. The multiphase open-pore foam materials developed so far are still scarce and can be manufactured by various methods, which are reviewed in Table 1 and later in the lecture. Methods currently developed to manufacture multiphase open-pore foams. Loading of new phases is achieved by one of the following two strategies. Loading particles, inclusions, are packed together with larger mortar particles forming a porous bimodal preform, or 2. Loading particles are covered by a mortar material and packed forming a porous monomodal preform. Preforms are infiltrated and the mortar material is leached away. As a result, composite foams or foams with guest phases are obtained. They show homogeneous dispersion of new phases in a continuous matrix. Represents the aforementioned material structures. In particular cases, loading powders are packed combined with larger mortar particles and sintered. The mortar particles are later removed to obtain an interconnected porous structure. Schematic drawings showing preform compositions, A and C, and the structures of the final materials, B and D, for composite foams, A and B, and foams with guest phases, C and D, obtained by preload of new phases in the preform. Loading of new phases is achieved by the dispersion of particles into the liquid precursor. The preform is leached away after its infiltration with the liquid precursor, and the final material shows a homogeneous dispersion of new phases in a continuous matrix. Material consolidation can also be obtained, instead of by infiltration, by electrochemical, deposition of a metal and/or the new phases on a leachable preform or a pre-existent porous material. The liquid precursor is an electrolyte that contains metal ions and dispersed particles of the new phases. Schematic drawings showing preform compositions, A and C, and the structures of the final materials, B and D, for composite foams obtained by preload of new phases in the liquid precursor processed by infiltration, A and B, or by electrochemical, deposition, C and D. Thin foams are normally manufactured by physical bonding or by gluing pre-existent monolith layers, herein called components, of porous and non-porous materials. The non-porous materials are considered the new phases which are integrated into a material with a layered structure and a non-continuous matrix. Joints are present in between components. Schematic drawings showing component composition, A, and the structure of the final material after components joining, B, for finned foams. Another way to fabricate finned foams is to perform a casting of a liquid precursor into a mold where pre-existent self-standing porous leachable preforms are conveniently located. As a result, monolithic finned foam materials with continuous matrix can be obtained. Schematic drawings showing a mold with pre-existent self-standing porous leachable preforms, A, and the structure of the final material, B, for monolithic finned foams. Loading of new phases is achieved by building an assembly consisting of packed or self-standing porous leachable preforms alternated with packed beds of the new phases in finely divided form, inclusions. After infiltration and removal of the leachable materials, a final material with a layered distribution of components and continuous matrix is obtained. Schematic drawings showing an assembly consisting of packed or self-standing porous leachable preforms alternated with packed beds of finely divided inclusions, A, and the structure of the final material, B, for composite finned foams.